What's up, everybody? Sparrow with a Gun here from Sleepless Nights with another episode on Space Engineers Programming 101. When we left off in the last episode, we were working on our solar array script that is designed basically to optimize the solar power without having to do anything. So, in the last two parts. The first one was getting the rotor to work, the second one was getting the piston to work. So now the X rotor will bring it up and down. I don't know why I went this way. It'll extend it and then it'll fold it back up, and the piston will go up and down. So now we're into the meat. We need the rotor here to spin when it's reached optimum and stop when it's reached optimum power. We also want, or I want, anyway, the, how do I put this? I also want to take into account depth or direction from here. So, for example, as the pistons are rising, because of where the sun is, this may be more optimum than fully extended in this direction. The trick is, if it's not fully extended, we don't want the piston to extend because it might still be within the confines of your ship or station. We also don't want the Y rotor to rotate, because then it could spin and spin into the thing. Those are the two biggest things we have to take into account when factoring in optimizing. Now, if you wanted to do a stripped-down version, let me know, because the stripped-down version would be after it's fully extended, then you run the optimization, and it will only spin in the proper direction and then stop. I wanted it to actually be fully optimized in that once you start the script, once it starts rolling like this, it's going to take into account the direction of the sun, so that if your ship is like where my back is, you might open the cargo door and go optimize, and it's like, it is. What do I do? You know. So I just want it to be able to make the most amount of power that it can. But in doing that, we also have to take into account the piston extension and the Y rotation at the top, and basically cancel them if they're not necessary. Now, I don't know if I have that failsafe in here. I did a lot of programming all at once. And I don't remember if I factored that in, but let's go over what's changed. First of all, we've got rotor XY piston like before. We do have a list of IMyTerminal blocks named panels. This is because what I ended up deciding to do was, instead of using one panel as a test panel, I want to take all of the panels' total power into consideration. So we have a list of panels that are IMyTerminal block. We have the extension and retraction lights, the upper and lower limit. We also added these. I changed these to float, current power, last power, optimum power. And optimum power is 120,000. Float, which is 120,000 or 120 kilowatts, which is the optimum power of a large solar panel. Again, if you want, this is not set up for small ships as of yet. All that would be required is to change the optimum power to large optimum power, and then have a small one, and then basically decide what kind of ship it is or stuff like that. But that's beyond the scope of what I'm doing in this particular episode. But let me know if you'd like it to work for small ships. I will try and add in a contingency for that. I also changed the rotor X angle variable to a float instead of a string, and I'm going to go over the changes I made there too. And then I've added a string state that's equal to start. Now, keep in mind, these are all global variables. They will instantiate at the first run of the program, but after that, wherever the program ends is where they will stay until you restart the game. When you restart the game, it will default to whatever these values are. After that, once it's run a couple times, it's going to stay at whatever they end up being set at throughout the code. Okay, so we don't really need this part in here. I just have it in case I want to write something on the screen. Rotor XY piston, grid terminal system, get blocks of type, IMySolar panels, or IMySolar panel, and then panels adds in all of the solar panels attached to the grid. Now, there may be a problem with this if you had other solar panels outside of the array. Again, that's a contingency we can work with, but for now I'm working on getting it to work. The extension lights, the first value inside the code to instantiate the angle, and then we have our main code. We have our setup. This hasn't really changed. We have our turning the rotors off, setting their braking torque, and setting the upper and lower limit of the rotor X. Turning the piston off, set up solar panels. I don't think I really need that in there, but whatever. I did change this, and this is, we're going to go over this in a minute. So if extended light is working, we call extend, else if retract light is working, we call retract. Otherwise, if state, that variable up here that we started, oops, well, that's interesting. Didn't mean to do that. Start. There we go. So, hold on. I don't know why I didn't think about this. Go away. It's like trying to give me epic music and I'm trying to explain code. It doesn't usually go hand in hand. Okay, so if these two aren't active, then it says else if state is equal to piston extend. In this case, the piston extend is the state, but extend is isn't being called. So it's already extended. And we're going to go over what that exactly means here in a minute. And then if that's the case, then we want to spin. And we'll look at that too. After this, I made this checking for state change, but after each run of each one of these three things, it's always going to run optimize power. And then it takes the panel list as an argument, and then this will go away when we're done. So we went over piston extend in the last episode, but what I've added to each of these, extend, piston retract, and retract, all of four of these have a set state value. So that state variable keeps changing every time one of these is run. So it's going to say I'm in the extend mode. I'm going to set the velocity, turn the rotor on, check the angle. If the angle is at a certain point, I'm going to set the velocity to 0, turn the rotor off, and extend the piston. Then when you go into piston extend, it's going to set the state to this, and then set the values, so on and so forth. What it doesn't do is change the state. So it's going to stay in piston extend mode. So if this happens, this is where we end up with this. If the light is off because piston extend turns the light off when it hits its proper distance. So if the light's off and retract light's not on, but the state still says this is the state, then that means the last thing that happened was the piston was fully extended. And in that case, we want to spin the Y rotor so that it can check for, if it's reached this point but isn't already in optimum power, then we want it to basically check and spin around to see what it's got. This may have to change depending on if we run into a problem. That's the only thing. I have to run this code and stuff and check to see if this is enough of a fail-safe to where I think it is, because if this is the state but the light is off, then it should already be fully extended, because it only turns the light off once it reaches its maximum distance. So I believe the Y rotor will not spin unless the piston is fully extended, and in that case you don't run the risk of it spinning around, because the piston extend method doesn't turn the light off unless the rotor extend method completed and then called its method. So basically, if these get interrupted at any point, the light should still be on until another method turns it off, which we'll go over in a minute. Alright, so all of these are the same except for adding state changes in each one. So that's all the really change there. And the angle is now a float value, so you'll notice it's like get distance piston equals 0.0 f instead of 0 in quotes. The reason for that is down here in the get angle and the get distance, I changed them to float. This is all the same, but then I just parsed the string into a float value and then returned that so that you could do math on it if it was necessary. Alright, and the spin function sets the state to spin and then sets the Y velocity, or the velocity of the Y rotor to 1, so it's going to spin in the positive direction. So now we get to the meat of this episode, which is the optimize power script or function. It takes a list of IMyTerminal blocks and it names them panels, so that's why we can throw in our solar panels. I have not run this, I have not tested it. I do not know if it will work. It's just theorem that I think I covered all my bases, but we'll find out here in a minute. Let's run through it though. So first of all, we're going to loop through all of the panels that are in the list, and we're going to add it to the current power value. Now, if you'll recall, current power defaults to 0. So we're appending, and again, I got this code right here off of the wiki, except for the name of your variable. So I put panels, I put this right there in so that you could get each array's or each panel's data. But the rest of this code from here came from the wiki, and it's basically a quick way. You can just paste this in and change the variable name right here to basically convert your kilowatts down to watts so that your math is easier if it hasn't reached kilowatts and so forth. And if it has, it's a good way to transition, so on and so forth. It's just easiest to break it down to its smallest increment and then do the math from there. Okay, so from this point on, current power, every time optimized power is run, will hold all of the current output that all of your panels can do that's connected to this array. Right? Well, actually, at the moment, the way it's scripted is it will hold any solar panels on your ship. Did not think about that. Hold on. I'm going to get rid of these, because I just realized these could cause a problem. It shouldn't cause a problem, because essentially what it's doing is it's taking all solar panel output into account. If those don't move, then it should not affect the algorithm. But just to be safe, at the moment for testing, I want to take it out. Alright, so let's get back here. So the first thing I do, we check current power if it's equal to optimum power multiplied by the amount of solar panels. So optimum power was designed with 120 kilowatts, which is the total amount of a large solar panel, not a group. So this multiplies it by how many panels you have so that it can check the current power and say, are you already at maximum power? This could cause a problem, and we might have to change it for one reason only. If not all of the panels are optimum, like if not every single one of them is outputting maximum power, this will always come back void. Okay, that's the big problem with this. So I don't know if it'll need to be changed or if it's good enough that it'll be fine. We'll have to find out. Basically all this was is so it doesn't affect any variables in terms of it doesn't, if it's actually fine and it's actually optimized, then just leave everything alone. That's why there's only a return function, so it would just close out the function and not do anything. The other condition is that state is not equal to optimize. If it is, then this will never get called. That's important. Alright, so then our second condition is if that's not true, and current power is greater than or equal to last power, and state is not equal to optimize. So after we do this, for example, this will probably have a value, and even if it doesn't, if they're both 0, it will still trigger this. If it's not 0, then this, and like last power hasn't been instantiated yet, then it's going to be 0, so it's always going to come back greater than or equal to this. So in that case, we're going to add last power equals current power. Okay? So what's going on so far, in case you haven't quite figured it out, is every time this program runs, while the lights are on, it's going to call extend or retract. Then it's going to check optimize power every second, every time it runs, every tick. So when that happens, it's going to compare the current power and the last power. If last power is less than this or equal to it, it's going to say last power is now equal to whatever the current power is, so that the next time you can run now what is the current power against what just happened in the last second. So that's what these two are doing. Hopefully. I hope I got this right. Alright, so if this isn't true, if current power is not greater than or equal to last power and or the state's not this, Then we move to this one. So it says if last power is actually greater than current power, or state equals optimize. Okay, so basically what's going on here for a visual representation is, just for example, let's say this is spinning. And it spins like this. Oh, I'm getting more power, I'm getting more power, I'm getting more power. Oh, I'm not getting more power. Now that's when this condition gets triggered. Is all of a sudden the last second when it checked against last power, now current is less than that. So now we need to revert it back to wherever it was, where last power was. So that's what all these states are for. Now, I haven't shown this. If you're not aware of what this is a switch case. It's similar to an if-else, but it's for if you have a lot of conditions. So a switch case is where you put one variable in, like a state, and then check to see what the state is equal to. And then you set up different cases in case it's equal to this, or to this, or to, so on and so forth. So the syntax is switch, close parentheses, a set of parentheses anyway, and then a variable, two brace, like a same as an if-else clause, you've got an open and a close curly brace. And then you have case, whatever the value should be, colon, and then at the end of your line you have break and a semicolon. This closes out each case. You can see it in every one. Okay, now we get into the meat of these cases. So, if it's in extend mode, and all of a sudden last power is now greater than current, what we want to do is basically reverse the process and then tell it to end once you go again. Okay, so it's already moved past where last power was at the last second, because this with the timer, this is going to run every second. So in that case, if it's still in extend mode, we want to turn the light off so that it does not do any further extension. We want the rotor value to be set to -1 so that it rolls back, right? For it basically reverses whatever it just moved forward for the last second, and then change the state to optimize, and then break. What this will do, the light is now off, so when you scroll up here, extend will not be called, which in effect cancels out piston extend. The state will equal optimize, so the spin function should not happen. Then it checks optimize power panels again. When it runs it this time, the state will equal optimize, so it's automatically going to call this, but now we're going to go down to the case of optimize. So now it's reverted from what it's done the last second, so it's back to where now current power is now greater than or equal to last power. So it's at optimum from wherever the extension period was. Now we turn off both of the lights, we turn off both of the rotors, we turn off we basically shut everything down. Okay? And then we set the velocity values for both to 0. And we also set the piston value to 0, and then we set the state to stop, because nothing in this code calls for a state of stop. So if state is equal to stop, then none of these cases will happen. So that's important. Now, there is one caveat to this, and it's something that, quite frankly, I really don't have a solution for. That is, if you are bringing the solar panel up, right? So I'm the solar panel. I'm in the default mode of laying down, okay? So if I start to extend it with the rotor, so the extend function is being called, oh, I'm optimized, or I'm not optimized, so let's bring it back, now I'm optimized, okay? The one caveat to this is it may in fact not be fully optimized. What it's basically saying is that for the x-axis it's reached an optimization. It does not mean that if you rotated the solar panel over it would be getting more power. But as I said before, if it's not fully extended to 90 degrees, so it's out of the your ship, and again, with this setup, the way that it's being designed, you could build your ship to where, you know, your ship's up this high. And in that case, you wouldn't want it to spin until the rotor's fully at 90 degrees and the piston is fully extended if your ship frame comes all the way out here. You would not want this Y rotor to spin at all until it reaches that point. So that's the only thing. You could set it up to optimize better, in that in every single possible direction, once the code is run, it will rotate and move things until boom, this is now fully optimized. The problem with that is it's hard to build a ship around it because it has to have some kind of collapsed function in order to do that, unless you're planning on doing this, you know, with it outside the ship, which is fine, but that's not what this was designed for. So if you try and use it in that capacity, it may not always optimize to the full power potential. All right. With that said, so basically that's how these work, is every state, if this happens and it's in these states, it will negate the state, reverse it for 1 second, and then tell it, I want you, the next time the script runs, to be in an optimized form, so that then when you go back, it's always going to go back to this one and turn everything off so it does not continue to reverse. So in each state, piston extend, for example, we don't have to do anything with the rotor because the rotor's already shut down. So we turn the light off anyway, and then we set the value to -1 to bring it back down just a hair. If, for example, it's in this state, but for some reason, I don't foresee why this state would ever get called, but it's in there. So it reverses and then optimizes, which turns everything off and resets the velocity. Retract works the same way. Except it sets a positive value instead of a negative value. Now, the only thing with this is if you're retracting it, you may not want your solar panels extended. So for that, we might remove retract completely, to where it's not a big deal if the last power is greater. Actually, you know what? I am going to do that. Both of the retraction methods I'm going to remove as cases. Because if you're folding the solar panel array up, you just want it to fold up. You don't want it to do anything. Now, because we have the spin function in place, we are going to have to work with the retraction method a little bit differently. Okay, so spin. Rotor-wise, velocity is negative because if you'll recall, in the spin function, we just went ahead and set it to a positive value. So it's going to spin in a positive direction no matter what. So if it's in the spin state, but the power fluctuates, then we want to back it up, go the negative direction, and then turn everything off like we always do. So that's how this works. Hopefully it works, but I've rarely ever had a single piece of code that I've ever written that worked the first time, so I'm not holding my breath. The other thing is we need to take into account with the retract method the spin cycle that's now set up. So actually what we need to do is piston retract. And in this method, if... Okay, so let's put all of this in an if statement. Let's do if state, or okay, now, see, this is one of the nice things. Now that I've changed the get angle to return a float value, I don't actually have to have a variable hold it. So we can do if get angle rotor y is not equal to, I think it's 0? Hang on. Oh, I don't... Well, let's check one of the other ones. Get angle r is equal to upper limit. Okay, upper limit is 90, lower limit is 0. What I'd like to do... What is the current... Okay, 360. So, what I want to do is in the piston retract method, where did it go? Okay, here it is. So what I want to do, we don't use decimal points, is not equal to 0, or get angle rotor y is not equal to 360. If that's the case, then we can go ahead and do all of this. That will basically say if it's not where it currently is, equal to 0 or equal to 360, which depending on the direction, it's like fully in the direction we have it built, then we can do all this. Otherwise, we want to I'm gonna need multiples, I think. Multiple lines. So we want to do, let's see, what do we want to do? Rotor Y, apply action, or no, set value. Velocity is, let's go with, well, hold on. What does our spin function do? Okay, that sets the state, though. So we don't want to do that, because we want it to stay in piston retract mode. Did I need to do a float for that? No, it's a single. It's so weird. I don't know why they use singles for this. Yeah, I think this will work, because this will keep, if the piston hasn't retracted, it defaults to piston retract, and that way if the angle for the rotor isn't set up correctly, then we set the value to 1, and then it's going to run through everything again. Actually, we don't need this, because we can handle this in one line. And that way it'll just keep setting the velocity until, and it'll keep checking the angle every second, and once the angle is equal to 0 or 360 depending on which direction it's spinning and where it ends up, then it will, then what we should do, where do we turn on the thing? I never turned it on, did I? Okay, so see, that's one of the problems. Where's spin? Spin. Okay. So let's do rotor Y, apply. Oh, we'll put that at the bottom. Activate rotor. Apply action. On, off, on. Okay, so spin, if the state is set to spin, then turns the velocity, applies the action to turn it on. So in this case, where piston retract is concerned, we need to set the value of velocity to -1, and then turn it back off. And that way, if the angle is correct, it will stop moving, turn it off, and then the piston can start to retract. Or no, wait, 0. I don't want -1. There we go. Alright, no errors. Remember that. Alright. Okay. Let's try this real quick. Actually, I'm going to... before we do all that, that was a lot of work, so let me save that. And then we'll turn this on. Trigger now. Should retract without issue, in theory. Looking good so far. I'm mildly confused why this timer block, though. It's set up to run the program and then trigger, but it seems like it's not triggering at all, like it's not even blinking. Alright, now let's try extend. Okay, see, that's what concerns me, is right now they have 4 green lights, but it's not stopping the piston thing. So, something in the code is not properly checking nor is it spinning. That's odd. It's like nothing's happening. It should have started spinning by now, unless the, okay, there's a problem with the optimization, I think. I think that, well, no. Because if the states in piston extend, and the 2 lights are off, the spin should just automatically start. Rotor Y, apply action on. I don't know why it's not spinning. That seems very strange. Why you no spin? Solar rotor Y? I think I have that set up right. Solar rotor Y, current angle 0. Oh! Wait a minute. Was it in the piston retract? That turns it, but it doesn't change the state. I have an idea. I've got an idea. Let's do this. Let's write state to the screen. And let's start. So it's in start. Well, that... Oh, okay. Piston retract. This is good. This will help us debug things. Okay. This will help us figure out what's going on. Retract. This is actually pretty cool because you can see what's really going on. I should also display current power and last power. Okay. That's what I should do. Let's do that. So in here, let's do state plus new line, current power plus last power. Oh, wow, there it goes. Oh, I am a flipping retard. Okay. I know the problem. I set this to always add to the value. So that's why it's in this ridiculously high number. Okay, so stop that. Stop. Just... Well, that's interesting. It's like constantly running now. Well, that was unexpected. Okay. Okay. So... let's set current power to 0.0f and last power to 0.0f. Just for a second to clear, because it is a global value. Duh. Okay. Oh, you know what? Let's set up available buttons. Oh, you can change the, oh, that's cool. Did not know that. Set up actions. Let's set this one to run. Oh, I see the problem. Well, that may not actually be a problem. What's going on, in case you were wondering, is... Let's see if I did this right. Let's check solar panel 1, 85 and 85, so that's about 170? Bingo! 170. Okay, so what's happening here is we have a line at the beginning to clear the values. But what's also happening is that down here it's always running optimized power every time it runs through. So what we might want to do is actually leave these in here. Let's back you up by 1. Oops. And we'll put you in here. So that way it can actually be accurate every time it checks. Alright, so now if we run this, it should not continue to climb. It should stay right where it is, which it is. Okay, so extending. So you can see the numbers going up because it's gaining more power. But see, like, right there, it's losing power, so it should be stopping itself, and it's not. Now, also, let's see if we can screw this thing up by doing that. Ha ha ha! So you can stop it in the middle. Cool. I like when my codes actually work. That's really cool. Alright, so we need to figure out why when this... Wait a minute. That's why. It's always equal to last power. Well, this is an interesting turn of events. Because what's happening is, for some reason, this is always being called... Okay, alright. I'm gonna do... What I'm gonna do is take this out, so that if it's equal to it, it doesn't matter. This is a predicament. So if current power is equal to optimum power times panels count. Makes sense. Actually, what I might do is let's just set. I have a better idea. Let's do this right here. We're gonna cut this out because it doesn't need to do that every time. That's redundant. Oops. So what I'm going to do is up here in the instantiation stuff, after it's declared its solar panels, like right in here, we're just going to say optimum power equals optimum power times panels count. There. And then we'll display this as well, so that we can see what our full optimum power should look like. Okay. Now we have to fix this down here. I think this state thing will work. What we have to do is figure out a way to where last power equals current power. Okay, I know what we'll do. We'll put this in here. If current power, or no, if last power is equal to 0.0f and current power is not equal to 0.0f. And no, we don't need all these brackets in here, but for me at the moment it's just a way to keep all my cases set up. Then last power equals current power. So this is our first instantiation if it's absolutely nothing. And this one isn't because it just ran through the loop. But if this is, then it doesn't reassign it, and the only way it gets reassigned is if current power is greater than last power. If they're equal, it doesn't change anything. Yeah. I think that will work. If it's greater than, it reassigns. But then if it's not greater than, then it sets that up. So that should work. We're gonna try it. Oops, I didn't mean to run it. Optimum power multiplied by panels count equals infinity? That seems weird. Unless it can't be held in a float value. That's weird. Oh! Wait, no, that should work. Because panel count should be 2. I guess... Let's do panels.count and see how many we're looking at here. Three. Why are there 3? Oh. Okay, so this is less than... So it's 0... Hold on. That would mean 0... Then... How is count equal to 3? That means it would still be taking into account 3 values. But there aren't 3 panels. Oh, wait a minute. Wait a minute. Yes, there is! I was testing something. I don't remember what I was testing. Oh, I was testing to see if the watts were there. Yeah, there we go. That's better. I still don't know why it's set to infinity, though. I don't know. It must be outside the float range, but it shouldn't be. 120,000 times 2 should be like 240,000. I don't really know why I can't hold... Whatever. It's a little bit irrelevant, actually. Alright, so now let's try this and see if it works. 222... Okay, last and current are still neck and neck. They're not... Okay, they're not working the way that they're supposed to. I need to change their update functions. Actually, before we do that, let's test the spin function. Let's see why that's not working. Because the solar panel side of things is definitely not being accurate, but it's because of how I'm updating current and last power. I know this. Okay, now it's set to spin. Yet it's not spinning. Why is it not spinning? Solar rotor Y, RPMs are 1. It's not on. It's set to be on. If it's in the spin function, it should be on. So, yeah. Rotor apply action on. So, oh, wow. Wait. Where's extend? Because this rotor's working. Set value, velocity is on, apply action on. So that works. Why is this one not working? Set value, apply on. Well, Okay. Something in here is calling for it to turn the Y rotor off. I know this one up here does, because we set them to turn off, but then we set them to turn back on, so it really shouldn't be doing anything. I don't understand why that function's not working. Because the state says it's in the spin state, and the thing's RPMs are set right, so I don't know why the rotor itself isn't turning on, especially when there's a line right here that says turn on. I don't get that. But I think we're about out of time. I know we didn't really accomplish what we set out to this episode. We're close, though. We're getting there. And I'm open to suggestions if any of you are familiar with coding and you have ideas on how to get things to work properly. The two problems that I'm having is why the Y rotor is off and how to properly update the last power against the current power, because seeing them neck and neck on the screen is what's keeping it from stopping the script if it reaches an optimum power source. But that's all I can think of is it's because they're neck and neck and it's not actually, it's not seeing a difference where they're ever greater than the last one for some reason. I don't really know why. Actually, I might. I am a knucklehead. It's because of this right here. Let's take this out real quick. Let's see if this works. Let's retract it. I'm thinking that's the problem. See, now it's actually something different. Okay. 191, 209, 59. There. That's what I needed. Okay. Okay. However, I need this to basically clear it. How about this? Let's put at the end of piston retract. Where's that? Piston retract. So if it gets to this point, it's done. So what I'm going to do is current power is equal to 0, and last power is equal to 0. So whenever you retract it, it's going to reset the values. That should fix our problem. Oh, right. Yeah. Actually, what we can do, let's move that to, let's cut this. We're going to move this right up to the retract function. It'll be right in the top. Because, like I said, once you set it to retract, we're no longer looking for it to optimize the power. Alright, so let's... Okay, why is that not clearing? It should be clearing. Let's see what it does when it hits 250. Haha! Success! Now it's slightly off. It's a hair bit off. But still, that's kind of what I'm looking for. Now we need to fix the spin. Let's retract it real quick. Oh, I see. It's because optimized power is being called at the end after... it's called every frame, or every second. So, even though retract is getting called to clear it, then it's getting optimized here. I see. Okay. We could add a simple line here at the bottom where if state is retract. Let's go ahead and do that just for continuity's sake. So if state equals retract, then we're going to current power equals 0.0f and last power 0f. That way it's done outside of the retraction method but gets the same result. That way it's being called after optimized power. Alright, start actions. Okay, and if I were to retract, clears the values. Perfect. And let's do this. Should be able to see the light and it go off. Alright, now this is not perfect yet, for the obvious reason of, you know, it's not completely optimized in that, let's actually check what these end up being. Yeah, 109 and 109, so they're not full 120, but the thing here is it's like the total is, that would be about 225 kilowatts and we're getting 219. So there's a fraction of a second where it's not recovering quite fast enough in terms of the cycle of set the velocity to go back one. And then what I don't know though is if I'm actually really happy with this script that it's starting and stopping like on command. So 223, 225, 209, or 220. Okay. So it's not being given long enough to basically back up to last power. It's backing up and then turning everything off too fast that it's not fully getting to that. Truth be told, I don't know if there's a way to fix that because that's very like nitpicky kind of numbers. Like that's really specific in terms of your outputs and stuff. But yeah, I'm going to try and work on the Y factor though, the spinning, because that way if it's not fully facing one direction, we're not going to have any issues. It's still going to spin around and find the best spot once the spinning is allowed. So let me know what you guys think about all that, and if it works the way you think it should, and all that kind of stuff. In the meantime, I hope y'all enjoyed. If you did, leave a like, and I will see you all next time. Peace.